Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 311. It's a medium level problem, and I also feel the same. I would say after a while, we are getting a good problem of tree. So yeah, the problem name is reverse odd levels of a binary tree. So given the root of a perfect binary tree, reverse the node values at each odd level of the tree. Right? For example, suppose the node values at level 3 are 2, 1, 3, 4, blah blah blah, then it should become just the opposite. You just reverse it, this array, so it becomes 18, 29, 11, and so on. So return the root of the reversed binary tree. A binary tree is perfect if all the parent nodes have two children and all the leaves are on the same level, right? So that is the definition of perfect binary tree. The level of a node is the number of edges along the path between it and the root node, right? uh, pretty I would say long problem statement. Let's look into the example and understand it. So example 1, we have a tree. You can see that, so the first level, the root node is obviously level 0, the second level is basically level 1, and so on. So the numbers start from 0. Consider each odd level. So you can see that the colored nodes 3 and 5, so they will be reversed. It will become 5 and 3, right? And you need to return the modified tree, the root of the modified tree. Let's come to the second example. So it is, again, see the colored nodes, it's 13 and 11, it will become 11 and 13, and so on, right? So I would say again an implementation based problem, but let's look into the explanation and then I'll tell you. So right, so here we have, I'm not writing the value, just suppose this is a tree, it's a perfect tree, so I'm trying to make a perfect tree, and I'm also trying to add one more level, just for, so that you guys understand, right? So dot 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 dot, right? So this is level 0, this is level 1, this is level 2, this is level 3. You need to consider these two levels, level 1 and level 3. We need to consider only the odd levels, right? What do you need to do? Suppose there is a value 1 here, there is a value 2 here. Now here we have 1, 2, 3, 4, dot 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 till suppose 8. So what it says, now the values will become, so here, sorry, here it was 8, right? So it will become 8, 7, 6, 5, dot 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 till 1. This is what the problem is saying, right? So don't apply too much logic. The only thing is the way you do in other tree related problems, right? What do you need to do? Just traverse the tree. You can do an in order traversal. You can do an in order traversal, because in order traversal will be left, root, and then right. So what do you do? Obviously you will be visiting this node first, right? Just consider this one, right? You will be visiting this node first, then this, right? So we need a list for each and every level. Like for level 1, we need a list which contains value something like 1, 2, right? Here also we need a list which contains a value that at level 3 we have node values 1, 2, dot 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 till 8, right? This is something that we need. So do a traversal, take a map. The key in the map will be the level, and the value will be basically a list of integers. Those integers are the values at that particular level, right? This is the step 1. Now what do you do in step 2? In step 2, again do the same thing. Again traverse the tree in the exactly same way, or you can say you can copy the same code. You can exactly copy the same code. We'll see that in the explanation. And all you need to do, the list that you have, suppose you reach at level equals to 1, so you have this list, right? So what do? You pick the last node, you pick the last value from that list and assign it to the current node, right? Suppose you assign 2 here. Now what you do, you remove it from the list. Now the next time in the traversal, when you come to level 1, you pick the last value again, and then you assign 1 here, and this list becomes empty. So what I mean to say, you need to reverse the list, right? What do? You again do an in order traversal. You start picking the last values, and obviously the way you will be visiting the node will be again as you visited in the first phase, right? Starting from left side. But however, from left side you need to assign the values from the right side. The value which was on the rightmost position needs to be assigned to the leftmost node. So the way you visit the nodes is same. The values that you are assigning is dependent on this list. So you are picking the values from the end of the list, right? So basic stuff, you just do this and you are done. So you can see here on line number 53, I have called a function in order, that is to construct my list, And on line number 54, I have called an in order update, that is to update my tree, and finally I have returned it, right? Now let's come to the separate functions. If I come to the first function on line number 19, so on line number 17 you can see I've taken a map. Integer is the level, and value is the list of integers. I've called it level vals. Okay, so just do an in order traversal, whatever you do. So in order traversal, what you do on line number 20, if root equals to null, just return it. And on line number 32 and 33, I've called it for left and right. Now comes the core logic from line number 23 to 29. What you are doing, you are checking the level. If level mod 2 is not equals to 0, that means it's a odd level. Then you check whether the map contains an array list for this level or not. If it doesn't contain, put it. On line number 25, we are doing it. Now what you do, you add the current node's value in the list for this particular level. That is what we are doing. We fetch the list on line number 27, we put the value, and then we again update the map. Basic stuff. Your map is ready in first phase. Now when you call the in order update from line number 54, you see I've copied the exact code. What I am doing, if level mod 2 is not equals to 0, that means it's a level which with which we are concerned, right? We fetch the list, and then we find the index, that from which index of this list we need to pick the value. Obviously that is the last index, so I've done vals.size -1, and then root.value equals to vals.getIndex. That means give me the value. Now vals.remove this particular index. So now your list is decreased by one length, right? And then levels.put, again you put that particular list into the map, and we are good to go, right? So very basic stuff. I would call it a relatively easier problem from the other third level problem that you get into the contest. However, I feel that this contest itself is very easy. But yeah, good to learn some new concepts, right? So again, if you learn something new from this video, do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, do mention that into the comments. If you want to connect with me, do connect with me on the LinkedIn. I'll be happy to do so. The link is mentioned into the comments. Yeah, take care. Bye bye.